be doing your math review today. Let's start out with number 1. With number 1, I had to draw a lot of number lines. So I needed to round the number 231 to the nearest tenth on a number line. So when I did it at first, I drew a conventional number line, and I thought, no, I'm rounding to the nearest tenth, which means I'm looking at the hundredth. So I need to zoom in a little bit. So my next number line went in between the whole numbers 2 and 3. I cut out the 0 and the 1, and I zoomed in on 2 and 3. And I know that 2.5 would be right in the middle, because 2.5 is basically, it is 2.5, all right? So when I break that down, I've got 2 and 1/10, I've got 2 and 2/10, I've got 2 and 3/10, and then I've got 2 and 4/10, and then I've got 2 and 5/10, my half point mark. So when I look at 2 and 3/10, between 2 and 4/10, there's another 10 in between there. There's 10 tenths in between 2 and 3, and then there's 10 hundredths in between 3/10 and 4/10. So that would look like 1, 2, 3. That's where 2 and 3/10 would be. 4, 5, 6, 7, 8, 9, and then there's my 10th, all right? So I tried to zoom in again even more, just between 2 and 2, but then I said, you know what, I can just do that effectively here. So if I'm looking at 2 and 3/10, here's my 2 and 3/10, and I'll even zoom in on the document camera. So this would be 2 and 31 hundredths. Then it would be 2 and 32 hundredths. So the reason why 2 and 3/10 would round to 2.3, 2 and 31 hundredths would round to 2.3, is because it's clearly closer to 2 and 3/10 than it is to 2 and 4/10. Because when I'm rounding to the nearest tenth, I'm looking at where my hundredth is and how close it is to that nearest tenth. So I'm not looking, is it closer to 2 or 3? I'm looking, is it closer to 2 and 3/10 or 2 and 4/10? So that's where I need to know that my 2 and 31 hundredths is right here. So I am way closer to 2 and 3/10 than I am to 2 and 4/10. Moving along to number 2. With number 2, I need to do 2/3 plus 6. And I'm sure a lot of you guys just went 2/3 plus 6/1, and then you converted this. You don't need to do that. 2/3 plus 6 is just 6 and 2/3. Keep it simple for yourself. Remember, when you're adding a whole number to a fraction, you can just pop those together. It's like having 2/3 of a dollar plus $6. Okay, number 3. Number 3 is asking me, why is 4 times 1/2 less than 4? Why is 4 times 1/2 less than 4? I need to tell you why 4 times 1/2 is less than 4. Well, if we calculate it out, I can do 4/1 times 1/2. So I know that that's going to be 4 halves. And I know that 4 halves is equal to 4 divided by 2, which is equal to 2. So when I'm multiplying something by 1/2, I'm making it smaller. So I'm going to say, when I multiply by 1/2, I am dividing the number by 2. And when you divide by 2, you're obviously going to get smaller. Okay? Next up is 4. So we've got, I need to find out how many minutes are in one day. I know one day is 24 hours, and I know 1 hour is 60 minutes. So I need to know how many minutes are in one day. And one day can also be called 24 hours. So if I know 1 hour is 60 minutes, I know I'm going big to little. So if I go 24 hours to how many, so I'm going to multiply 24 hours times 60 minutes, okay? 24 hours times 60 minutes. 12, 13, 14. And I'm a little tired this morning, so I'm going to check this out on my calculator. Is 1440. All right, so 1440. That's how many minutes are in one day. Okay, do you see how I did that conversion from big to little? Moving on to number 5. 3/4 minus 2/8. Well, it's a pretty straightforward. I cannot add or subtract if I don't have a common denominator. But already in my head, I know that 8 is a number that 4 can go into. So I'm going to take my 3/4, and I know if I multiply 4 by 2, I can get my common denominator of 8. But what I do to the numerator, what I do to the denominator, I have to do to the numerator. So my new setup is 6/8 minus 2/8. And now nothing is going to change with my denominator. And 6 minus 2 is 4/8. And I could even whittle that down. When we were talking about those halves, I know that 4 is half of 8. So I know that's equivalent to 1/2. Okay, moving on to number 6. 4 divided by 1/5. This is the equation we see for a lot of those problems that say I have, there are 4 days and I walk 1/5 of a mile every day. How many days would it take? So this is the kind of situation we're looking at. We're dividing the whole number 4 by the fraction, which is interesting because when we multiply by a fraction, our number gets smaller. But watch what happens when we divide by a fraction. So if I have 4 divided by 1/5, I want to know how many fifths are in 4. I'm going to draw a model here. 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 5. 1, 2, 3. 1, 2, 3. I want to know how many fifths go into 4. So if I look at this, I've got 5 here, 5 here, 5 here, 5 here. I know that this is 20. 5, 10, 15, 20. So I know that 4 divided by 1/5 is 20. Another way that I can do that is I can say 4 times 5/1. If I am dividing by a fraction, I flip the second fraction and I multiply. So I know that 4 just becomes 4/1. 4 times 5 is 20/1, which is just equivalent to 20. All right, for our POD, let's look at that. For our POD, we know that there are 950 students. Each student is going to get 2 popsicles. Popsicles come in boxes that have a dozen, so that's 12. And there's 25 boxes in a carton. The principal says there's going to be a perfect share. The secretary says there's going to be some left over for the teachers to have. I did some of this work. So my first thought was I need to know how many total popsicles these kids want. So I know that there's 950 kids, each kid's getting 2. So I know that they need a total of 1,900 popsicles, 1,900 popsicles. And I know that one carton is 25 boxes, and I know one box is 12 popsicles. So in one carton, you're getting 300 popsicles. So I noted that here. One carton is equivalent to 300 popsicles. All right? The principal says it's even. I know that 1900 divided by 300, if I take out those zeros, I know 3 isn't going to go into 19 equally. So if there's 6, I'm only getting 18. If they order 6 cartons, because there's 300 popsicles in each carton, if I order 6, I'm only getting 1,800 popsicles. I need 1,900. This is what I need. So I'm thinking that we need 7 cartons, because 7 cartons will be 2,100. I need 1,900. So there will be some left over. So they need 7 cartons, obviously, to get that 2,100. And there will be some left over. It's not going to be that perfect share. I want to show you another strategy of how this was done, with the same problem. They used a table, which I thought was a very clever way. So they know if they got 1 carton, they would get 25 boxes and they would get 300 popsicles. And if they got 2 cartons, so we're just doubling, doubling, doubling. Once they got to 6, they find out that they only have 18 popsicles, and then 7 would be 2,100. So they say they already know how many popsicles they need, and there was a remainder with the 6 cartons, so they say round up to 7 cartons, and there'll be some left over.